Oh, I guess my mic is still on. Jeez. Well, that just... what? Hello, everyone. Good morning. Good morning and welcome to Mr. Moore's Hour of Oasis and Serenity. Starting your week off right with lots of programming facts coming at your brains. Here we go. Hopefully everybody had a good weekend. I know I had a very restful weekend. Hopefully everybody's doing well today. Let's talk about some programming and junk. How is everybody doing today? Hopefully doing well. So we should get moving, eh? We're a little bit behind on the lecture material, so let's see how far we can get today. Good. So, it's your birthday! Well, happy birthday. Happy birthday to Lacey. Everybody say happy birthday in the comments. Yeah. There we go. Happy birthday to you, happy birthday to you, etc., etc. Sorry, full version of the song Happy Birthday is only available for premium subscriptions. So anyway, let's round out this topic 1 slides right quick. So, just a little bit left to cover. Last time we were talking about the difference between declarative, imperative, and logical languages. It's not actually important for you to know to be able to program in Python. Python, incidentally, is an imperative/procedural language. It's just like for your greater awareness of computing as a discipline. But essentially, imperative languages are languages in which you provide instructions to the computer. Declarative languages are languages in which you provide descriptions to the computer. So you describe a calculation rather than instructing the computer to perform a calculation. And, there's a certain amount of overlap between these things. And then logical languages, that's just a whole nother boat entirely. You don't want to have to worry about that. So, one of the differences between, So, there are differences between programming languages, obviously. Otherwise, there wouldn't be multiple programming languages. This is more about the differences between different imperative languages. So, examples of imperative languages are things like Java and C and Python, and C++ and C# and JavaScript, etc., etc. There are a lot of them. So there are differences in notation. You require different symbols in order to do the same things in different languages. So in some languages, you use Python 3. In some languages, you would use a exclamation mark equals to mean not equal to. This is an inequality relation. We'll get into equality relations. In some languages, you use slash equals because that's a little bit closer to the actual mathematical notation for the symbol not equals, which is a slash through an equal sign. But a lot of this is just like, I often compare it to playing Bloodborne after having played Dark Souls. The main thing that you have to do is figure out what they renamed everything. Python likes to think of itself as, much easier to pick up because it relies on a more simplified syntax. But those of us who actually know what we're talking about when we're talking about programming language grammars know that they haven't moved. It's not like in Python you have to provide less information. It's just they load that information into things that were standard practice but not technically required in other languages like C, like the indentation scheme. The indentation scheme that's used in Python is actually highly similar to something you would see in C or C++ or Java. They've just invested and imbued the tab, conventional tabbing of the various parts of the program. They've invested that with the weight of actual semantic content, whereas in other languages, the fact that you terminate a line with a semicolon, the semicolon itself indicates the end of the line, or the curly braces indicate what's inside of an if statement and what's not inside of an if statement, whereas in Python that functionality is imbued into the tabbing. So it's not like they got rid of the necessity to specify that, they just relocated it, if that makes sense. Anyway, one of the bigger ways that programming languages vary from each other is the degree to which they check data types. So if you program in a lower level language like C, C does practically no work on your behalf. Which, a lot of people find C programming to be more difficult because the C compiler does basically nothing for you. Whereas the Python interpreter does a whole heck of a lot of work on your behalf. But the advantage of C is because it's not doing all that work behind the scenes, it's not doing all that work behind the scenes, because that work behind the scenes takes time and energy, right? So one of the things that Python does behind the scenes is it does a lot of work to make sure that you don't have to worry about static typing. So some of you who already know programming, a certain amount of programming, will maybe be aware of the difference between static typing and dynamic typing. In Python, if I have a variable x, I can assign it the value of 7. It's 7. 7 is an integer, right? That is stored in a particular way inside the program. I can then assign it something else, like the string hello. And it just reassigns the data type of x to be a string now. It does that in the background. In a programming language like C or C++, you'd never get away with this, because this would be an error. It would be like, what are you doing to me? You declare this variable as an integer, and now you want to put a string in it? Do you have any idea how much space a string takes up? I just don't have the room, man. But also in a programming language like C, the syntax for declaring x, the integer x, as equaling 7 is like that. It has this keyword in front of it where the actual data type of the variable is like it's invested in the variable at the time of the variable's creation. There are ways to get around it, but that's sort of neither here nor there. In Python, you don't declare types with things, so things can be of like you can mix and match types. You can do everything you want, and to some degree that makes programming easier for beginners because it's one less thing you have to worry about. But any veteran programmer will understand that one of the ways in which you ensure correctness in your program is that all of the variables are being used according to the types they've been declared with. So, while it makes entry easier, it also allows for a class of errors that aren't possible in C or other statically typed languages, which can be very useful. But anyway. Support for large programs. Generally speaking, when we say stuff like, oh, it supports large programs, what we're actually talking about is abstraction mechanisms are provided which allow you to work with larger, more complicated things more easily. Generally speaking, when we talk about this within the procedural context, we are talking about classes. Do you have classes available to you? We're going to get into classes. We're going to spend a couple of weeks on classes later on in the course. Around week 8 and 9, I think, are classes and object-oriented programming. So in C, you don't get those mechanisms of abstraction. All you have available to you are function declarations and structure declarations, which is kind of like packaging data up. In Python, you do have classes. Unfortunately, they suck in Python. They're really not good. If you compare classes in Python to classes in pretty much any other object-oriented programming language, the classes in Python are extremely clunky and like just a pain in the butt to use. Not like if you're going to do anything heavily invested in object-oriented programming, I highly recommend learning another language in its entirety and then using that language. Like learn C++ or something. Because Python is just, there's a skill cap there. And, a diehard Python programmer will, of course, contradict me on that, but, whatever. This is actually a lie. You can do exceptions in C. It's just they're not quite called exceptions. Anyway. You also, one of the other ways in which languages vary from each other is the level of support that's provided by their libraries. So Python is a very popular language. So a whole heck of a lot of investment has gone into Python in terms of developing useful libraries for it. So, and we're going to see this a little bit when we get into, like, graphing, for instance. You can use Python in the same way that you'd use something like MATLAB, even, for, like, data analytics and that sort of thing. And, machine learning, there's a lot of machine learning support for Python, and it's like, import a library, and you've got all of this code base available to you. And it's like, yes, the size of the existing code base is really important for, your ability to program in that language. Something like C has, like, a very small number of supported, functions, supported library operations. But the reason for that is because C is it's an operating system language. C is the language that a lot of the operating system is going to be written in, that whatever operating system you're using. So in order to include something in a C library, like the amount of work that it is to include something in a C library is quite large as compared to something like C++, Java, or Python. So that's why the libraries are kept small. Anyway, another difference is portability to other platforms, although this isn't really a big problem for most general-purpose programming languages. So Python, then. Why Python? Why are we learning Python? It's a general-purpose programming language, so pretty much anything that you want to do in programming can be done in Python. Again, it's just a matter of how difficult is it in Python relative to some other language. It is primarily an imperative/procedural language. It can be used in an object-oriented manner. It can be used in a functional manner, although, functional programming language purists, such as myself, always say that the only real functional programming language is Haskell, because it's the only purely functional programming language. And because Python can express these different... it has essentially over time integrated elements from these other paradigms into itself. It is considered a multi-paradigm language, though the degree to which that's useful, your mileage may vary. Python considers itself to be a high-level language. It supports many mathematical data types, mathematical abstractions, and it has lots of standard libraries, sure. Fundamentally, though, like on a line-by-line basis, Python actually doesn't look too dissimilar from C. It's an interpreted language, so there is this process that's sitting on top of your operating system that's interfacing between, your operating system, your kernel, and your CPU, and the actual language itself. The language is fed into the interpreter line by line and executed, rather than being compiled all in one shot and then executed all in one shot, like it is what you would do in C or C++. It's dynamically typed, which I've already touched on. It's compact and intuitive notation. The degree to which you find Python intuitive is going to be... You're going to find out exactly how intuitive Python is when you guys start doing assignment 1. White space is important. That's an important thing to know. Python is widely used in industry, depending on which industry you're in, and how recent the code base is. Why is it called Python? It's called Python because of Monty Python. It was created in 1989 by Guido van Rossum, who is a fellow from the Netherlands. It is a, quote, open language. Every year they have a Python conference where a bunch of Python nerds all get in a room together and explain to the world why they didn't include switch cases. Python 2 is dead. Long live Python 3. So if you're downloading a Python interpreter, make sure it's Python 3, because that's the recent and supported one. The language is named after the British comedian group Monty Python, which, if you have noticed the Avenue button graphic, this is a scene from that show, called a very famous sketch from that show called The Spanish Inquisition. Nobody expects the Spanish Inquisition. It's really funny. I recommend everybody watch it. That's your homework. So, anyway, that'll round off topic 1. Boom, ba-boom. Let's see if we have any questions. Just a bunch of happy birthdays. Cool. Wonderful. So let's start getting into some of the meat of the topic. Let's talk programming properly. So, over the course of this set of slides, we're going to talk about operators, variables, comments, booleans, functions, tuples, and strings plus operators. So, I hope you've all got your thinking caps on. I've already demonstrated a certain amount of this, but we'll go through it again anyway. So, if you have the Python, like I'm going to use the Python interpreter for a lot of this kind of stuff. If you've downloaded the Anaconda distribution, you should be able to open the Python interpreter up in Windows PowerShell and do exactly what I'm doing. So if you want to follow along, that would be a wonderful thing to do if you're on a Windows machine. If you're on a Mac, then you can open up your terminal, and if you type in Python 3, I think, then you should be able to get this. And if you're on Linux, then you probably already know how to do this as well. You can roughly do just what I'm doing here, because I'm doing this in Linux. So anyway, the Python interpreter, this guy right here, is the process that executes your Python scripts, right? I'm just, rather than writing all of my lines into a file and then executing that file all at once, I'm entering the lines in one by one into the interpreter directly. So, you can use Python like a calculator. 5 times 8, or 5 plus 8 is 13. 5 plus 7 times 9 minus 2. You can do basic arithmetic, right? If you want to do exponent, that's 2 star characters. All right? Good. If you do operations that result in a decimal number, right? Like 7 divided by 2. Or something that's repeating. There we go. So this is an interesting one, right? Normally, you would expect, 2.333333333 all the way on down, but you got a 5 on the end there. So floating point notation is a little bit weird. We're going to get into it, but it's, for the moment, it's only important to know that a floating point representation is only going to be good to a certain number of decimal places, and after a certain point, you want to not, like, you'll want to keep in mind that a decimal number cannot be represented with exact precision within a computer, so you have to pick, like, a cutoff point with it. And we're going to see how that works. So, numbers like 3 and 2.5 in our source code are objects. Specifically, they are literal scalar objects. An object is something that can be operated on. You will also hear me call them operand. They will be operands. Operator, operand. There we go. They are scalar, which means they are indivisible and not comprised of subcomponents. So, for example, if I have 3 plus 5 within brackets, that is an object, but it's a compound object, right? A scalar object would be the 5, because there's no, you can't break it down semantically any further than the number 5. And most commonly, you'll hear me refer to these as literals. It represents directly in the source code what it says it is, as opposed to being computed or the result of another operation or being a memory, like being an element of memory. So if I put x in there, if I put the value x in this equation, oh, it's still a string. Let me assign it a value. 3 plus x. X is a variable. They're not the same as algebraic variables. They're correctly thought of as memory cells that contain data. The 3, however, it doesn't have to ever be entered into, like, the 3 isn't stored in the same memory as the variable, right? It's stored in the instruction, the way that you can think about it. This makes it a literal. This is literally a 3. X can be a lot of different things, but 3 can only ever be 3. Hopefully I'm not belaboring the point. Let me see if there's any questions. Are only prime numbers scalar? No. Any number is scalar. When it's talking about divisibility here, it's not talking about algebraic divisibility. So it's not like 9. The number 9 is divisible in a numeric sense. You can divide it by 3 and get 3. Sure. But when we're talking about divisibility here, we're talking about grammatical divisibility. Right now we're talking about programming language grammar. Grammar. Grammar, grammar, grammar. Not number, grammar. So, even though you can take the number 9 and you can divide it numerically by, whatever to get whatever. Division, whole number division is a valid operation on 9. So in a numeric sense, it's divisible. The number 9, as expressed in a programming instruction, cannot be broken down into smaller instructions, right? This guy, for example, 9 plus 7, right? 9 plus 7, once it's in brackets, that is an object, but it's not a scalar object, right? It's a compound object because it is composed of 2 literals and an addition operator, right? We can take this object and we can break it down into other objects, right? We can break it down into 2 objects and an operator. 9 cannot be broken down further into objects and operators. Therefore, it is scalar. Hopefully that answers your question. That was a good question. I liked that question. Cool. So, scalar object types. I've already talked about these a fair amount, but here we go. There are 2 primary numeric types that you have to worry about. Integers and floating point numbers. So, an integer represents positive and negative whole numbers. Sometimes in languages, you have to worry about there being a limitation to the size of an integer based on the number of bits that are contained in the underlying data representation in the memory. Like if you were programming in C, you'd have to worry about that. But this is another case where Python is doing work in the background to not have to require you to worry about that sort of thing. In Python, your integers can be of hypothetically unlimited size, although everything on your computer is limited by the amount of memory that's contained in your computer system. So, but, it's unlikely that, like, if I filled this screen with 9s and it was like, a million screens of 9s, I probably still wouldn't have exhausted my computer memory. So, in a sense, it's functionally infinite. But, 9 is an integer. 89 is an integer. Anything that doesn't have a decimal place is an integer. If you want to represent a whole number as a decimal, you put 0.0. This changes the data type to be a floating point number. So real numbers, that is to say, real numbers as distinct from the integers, one is the big Z with the line through it, and the other one is the big R with the extra line. Real numbers in the the sort of formal mathematical definition sense. These are stored as floating point values. Floating point is just a computer speak way of saying, essentially, we're storing them in scientific notation. So these numbers get stored in like a facsimile of scientific notation inside of the computer system. And they operate differently than integers. The operations at the level of circuits, at the level of how they're dealt with at the CPU, they're dealt with very differently than integers. The operations are almost entirely dissimilar. We're going to get into floating points quite heavily in a couple of weeks, but just be aware that if you want something with a decimal place, it's going to behave differently than an integer. So, operators and expressions. Operators can be applied to objects to form expressions that yield other objects. So, when I was saying things like 3 plus x, or, 9 plus 7, the name for this compound object is an expression. Expression parsing is a very important thing in programming languages. So, in programming languages and in regular mathematics, you have binary and unary operators. You actually also have trinary operators, The only real example of that is the ternary expression, which is like a compact if statement, and that it's very different in Python as it is in C, but, we won't get into trinary operators. So, plus takes two things, so it's binary. Multiplication takes two things, so it's binary. Division takes two things, so it's binary. Something like negative. So this is interesting, right? Negative 7, as expressed here, this is not even... so negative 7 isn't a literal. It's positive 7 with the negation operator applied to it, right? So this is actually, technically speaking, not a scalar expression, not a scalar object. But that's, you can, functionally speaking, it doesn't really make a difference. Are floating point numbers what the F stands for in flops? Yes! Yes, it is. Flop means floating point operation, right? So, way back, when we were talking about, like, how good is your computer, they used to measure it in things called, like, megaflops and gigaflops. So within the architecture of the CPU, you will have specialized circuits that are designed specifically to accelerate floating point operations. This actually had to do because back in the 90s, the number of bits that were used to store an integer versus the number of bits that were used to store a floating point number were actually different. Floating point numbers were at one point double the size in memory as a integer. So it's kind of like the number of bits that a CPU can execute on in one clock cycle. That's like the bitedness of your CPU. So if you're talking about like an 8-bit CPU, that means that the CPU performs operations on things of size 8 bits, right? So the Nintendo Entertainment System operated on, 8-bit integers. Back in the 90s, you would have 16-bit integers, and floating point numbers were either 32 or 64 bits. So essentially what they would do is they would have a specialized floating point operation circuit that was embedded in the CPU that was a separate circuit that would be loaded differently than the regular integer math. That's why floating point operations used to be a lot slower. But now, since pretty much everybody's working on 64-bit operating systems and 64-bit CPUs these days, you don't actually require specialized floating point circuits to be able to accommodate operations of size 64 bits all at one time. Although, again, the circuits are still very different from the integer circuits. So, we don't really talk about flops as being a measurement for how good a CPU is anymore, because the number of floating point operations that a CPU can perform now is not distinct from the number of integer operations that they can perform now, because everything's on the 64-bit sort of level playing field now. But anyway, that's a good question as well. So, you can learn what type something is by using the type function. So type of 3 is class integer. So everything's a class because this is object-oriented programming. 3.0 is a floating point number. So here's a question. What's 3 plus 4.0? That's a float. So floating point representation is, it's kind of like an amoeba that absorbs anything it touches. Unless you have done something to, specify that the result of the result of the operation needs to be an integer. When a floating point number touches integers, it turns them into floating point numbers. That's one way to think about it. I think round, you can get a get away from that. Maybe? Yeah. So if you use the round function, that will turn it, it'll round it to an integer, right? And then, you know, you're back in integer land. But you have to do that explicitly. Even if you're a whole number, you'll still be a floating point. Boop. So, here is a table of your basic binary arithmetic operations. I.e., this is how you perform basic arithmetic. There are some important things that you probably will have never seen before on this slide, so we'll go over them. Addition and subtraction and multiplication, I really hope that you have seen those before. If not, then perhaps that you need to head back to elementary school. In division, though, division is kind of interesting because we have a distinction between integer and floating point division, and we also have a remainder operation, which is actually extremely useful. So let's say we have two numbers that don't divide evenly. Let's say we have 13 and 7, right? So if you use single slash, it'll calculate out the decimal place, and the result will be a floating point number, even if, as in this case, both of the operands are integers, right? So two integers that create a float. Bam. This is floating point division. If you wish to perform integer division, you use 2. So what this does, this is like long division. So hopefully all of you remember long division from elementary school. When you perform long division and you're not calculating out all of the decimal places, you will say 7 divides 13 once, remainder blah, right? In this case, it would be remainder 5, right? So in order to access the remainder, you use what is called the modulus operator. Oh, 6. Sorry. Ha! Sorry. Who needs to head back to elementary school? Might be your professor. So, anyway. So, if you were to do the long division, right, you would get, 7 divides 13 once, remainder 6, right? So, this is another way of thinking about this operation is it's this guy, but you are truncating the decimal. So truncating is probably a verb that you haven't heard before, although technically it's a noun because it's being used in the gerund case, but that's okay. To truncate within the context of computing means to chop it off, right? It's kind of that's kind of how it's used in regular speech, in regular parlance as well. If you truncate a speech, it means you're cutting yourself off at a certain place. So, in this case, when you truncate a floating point to receive an integer, you are cutting it off at the decimal place. So it doesn't matter if the number would round to 2 because you're not rounding it. You're chopping it off and throwing away the rest, right? So that's what integer division does. And modulus, this is a really cool guy. So, for example, modulus is really useful for creating cyclical behavior from counters. So if you have a program that is every time a loop executes, a number is increased by 1, but you want that to oscillate between 0 to 5, then you would just call modulus 6 on that counter, and then you could get a number that oscillates between 0 and 5. So let me see if I have any questions. So integer division just takes the floor of the quotient. Yes. If you know what a floor operation is, yes. Floor and truncation is exactly the same thing. A lot of people, I don't know. I don't know if a lot of people know what a floor operation is outside of either, you either have to be in the math department or in the computer science department to already have known what a floor is, but I think. But yeah, you can actually as well call... Yeah, so if you... I think you can just go floor. You might have to import math. Yeah, import math floor 13 divide by 7. Maybe not. Okay. Is it math dot floor? There we go. Math dot floor. Yeah, so it's the same thing. Coolio. And as I already stated, if you want to exponentiate, you use 2 stars. So if we are to use these operations and compose expressions from the operations, it would be good if we knew how those expressions are going to eventually be executed. And of course, generally speaking, BEDMAS applies. All types of division, including modulus, are sort of grouped in the sort of DM level, right? So modulus binds at the level of multiplication. However, as with regular mathematics, it's always if there's any ambiguity and you wish to resolve that ambiguity, you can always add your own parentheses. One interesting little thing, though, one way in which programming in general does not operate the same way as mathematics is in mathematics you could do an expression like this, right? That would be 6 plus 8 times 3. However, if we try to execute this within Python, it says int object is not callable. So the problem is that when you have a function call, right? The programming language isn't that great at resolving the difference between a literal and a function name. So if we have, for example, the max function, the syntax for calling the function is to put the parentheses immediately after the name of the function without any symbol in between. So max of, like 1, 2, 3, 4, right? There we go. When you do this guy, you're using the 3 as if it were a function call. So it's going to interpret it as a function call, despite the fact that you didn't intend that to be the case. So if you want to perform that type of operation, you must include the multiplication operator explicitly. That's, hopefully that allows you to avoid one of the common pitfalls of going from mathematical notation in algorithmic, or going from, like, algebra to programming. That's one of the common, like, I'm not sure why this doesn't work. This works in algebra. And it's like, well, it's because it thinks you're calling a function right there. Okay, so question about the assignment. If you accidentally submitted an empty one, can you resubmit? You get infinite resubmissions, so you can submit as many times as you like. We will always take the most recent submission. So whatever your most, it's kind of like Price is Right, as close to without going over the due date. Although if you submit after the due date, that'll erase, the new submission technically actually erases the old submission in the Jupyter system. Like, we don't even have access to the old submissions, so bear that in mind when you're submitting stuff. Yeah, and yes, do not rename the files. Don't change the name or else it won't get graded. Yes, that's good. Good. Yes. So you remember that thing I was saying about how floating point numbers are not quite precise? Here's an interesting little thing. So if we add 0.1 plus 0.1, 3, 4, 5, 6, 7, 8, 9, 10 times together, what should the answer be? Right? 0.1 added to itself 10 times, well, no, 9 times, technically, should result in 1, right? Instead, you get 0.999999999, etc. This is because, this is for reasons that we'll get into later, but essentially, it's the inability to represent a decimal number exactly within binary notation, which is only really a problem when you... so essentially the problem is floating point numbers are stored in binary notation. It's like binary, but you apply the rules of scientific notation to it. So when you're working with decimals in bases other than 10, it is possible to have a number with a finite representation in decimal that has an infinite representation in a different base system. And you can, like, for example, if you had a numerical system that was base 3, right, the number 1/3 would have a finite representation within a base 3 number system, right? However, in decimal, that's an infinitely repeating sequence. Like, that's an infinite you require an infinite number of digits to represent that number completely accurately. Because in a computer, we do not have an infinite number of, we do not have an infinite number of decimal places available to us because, computers are finite organisms, similar to ourselves. The thing gets cut off at a certain point. Like, it gets, you can only have it represented with so much accuracy. So, the binary representation of 0.1 is actually very slightly less than 0.1 in the decimal sense. It's like close enough to be good enough, in most cases, but, it's not precise and exact, which means that if you perform operations on these things, the errors can accumulate. So despite the fact that 0.1 is equal to 0.1, when you perform floating point operations on something in succession, these errors will accumulate sometimes and cause problems. But we're going to see this in a couple of weeks. We're going to have a lot of discussion about this, so I won't belabor the point. So, many of your traditional math functions can be used inside of Python and other programming languages as well. We import the math library. I already imported it to access floor, but if you want to do math.sine, math.py, for example, there you go. Math.cos. There you go, right? Math.square root. So, don't ask me why, but every single programming language I've ever encountered abbreviates square root as squirt. I don't know why, but that's what it does. So anyway, there are various math functions available to you. If you check out the Python documentation, Python documentation math library. This is a listing, So this is a listing of all of the different math functions that you have available to you. Ba-boom. Including truncation. Ha-ha! Whoop, there we go. With documentation and all that kind of fun stuff. So, you have the tools available to you. Yeah. Yes, the midterm is February 6th. Did we already learn enough to be able to finish the first assignment? Yes. Yeah, actually, within these slides, we just covered about enough, as much as you will need. I don't even think you technically need variables to do the first assignment, but they're helpful. So, on the subject of variables, haha! So, variables are named with objects. So, in a computer, if you wish to store data in memory, you do so with a variable. Variables are segments of random access memory. So this is your system's impermanent memory. It gets wiped every time your computer resets. It gets stored in the RAM, and you can put a value into it. You can take a value out of it. Generally speaking, the rules for variables are the same as the rules for files in your operating system. If you imagine you're working on a Word document, and you are typing away, you're doing stuff on your Word document, you hit save, the old version of your document ceases to exist, and it is completely and immediately replaced by the new copy of the document that has been saved, right? This is the same way that variables work. So if I have a variable x, and its value is 9, and I assign to that variable the value of 5. If I ask for the value of 5, or if I ask for the value of the variable x, I will get 5. It no longer remembers that 9 ever existed. You should think of a variable as a box that contains a number. And whenever you put a new number into the box, the bottom of the box opens and lets out the old number and then closes and then stores the new number. That's how a variable works. So variables can be extremely useful. So if, for example, one of the uses of variables is just to provide useful names to the things that are going on inside of your calculation. So, for example, if we were calculating the area of a triangle, we would say base is equal to something, height is equal to something else, and then area is equal to base times height divided by 2. What is the area? It is 17.5. Right? You can use this to, document your code. Generally speaking, it's always good to use descriptive variable names. You should be able to come back to your program in 2 weeks' time and be able to know what the purpose of the variable was from the name that you gave the variable. It's extremely tempting for brevity to say, x is equal to 5, y is equal to 9, and q is equal to x times y divided by 2. It's like, sure, all right, but we have to intuit that what we're doing there is we're performing a calculation of area. This could be anything. We have no idea what the context in this of this would have been. We don't know what we were getting at. And this is particularly of importance if you ever have to write code with other people. In this class, you won't have to do that, but, Anyway, that's class. I'll answer any questions that you may have. But, yeah. Oh, yeah, log 2 is log base 2. Log base 2 math dot log base 2 of 64 is 6. 128 is 7. If you want base 10 logarithm, maybe. Is that base 10? I don't know. Law, math. Because that shouldn't be. Maybe it is? Maybe it is. Maybe I'm just... Hup. No, it must be E or something. Math.E? Yeah! Okay, so log, just log, that defaults to the natural logarithm. So ln. Math log 10 would be probably the way they do that. Yeah! Cool. Logarithms. You submit your assignments on either Avenue or Jupyter. Jupyter also has a submission mechanism. I would recommend trying to use the Jupyter server if you have a VPN available. So, yeah. Yep. Yes. Yes, Stack Overflow is your friend. I downloaded the assignment twice so it appears as A11. Should I rename it to A1? Yes. Yes, you should. Yes, yes, yes. Yep. The mechanisms for submitting your assignments, it should be clear from the syllabus. If it's not clear from the syllabus, then it should be clear from the tutorials. And if it's not clear from either of those, ask your TAs. You found that log is equal to ln the hard way. Yeah. My god. Yeah, don't even get me started. I wish I'd known that before doing the assignment. That was so confusing. Yes. But now you know. You know? Never look at struggling with a problem as being useless. Struggling with a problem is always useful. In fact, the intention is that if it's too easy to do an assignment, then you're not learning anything, Are the assignments always due Sunday midnights? Yep. 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 Assignment 1 being due this coming Sunday, which is the 31st of January. Yes. Yeah, I'm going to have to pick up the pace with the lectures in order to get everybody on board with the assignments as they're coming out. But I don't regret having spent so long on topic 1 because it took that long to get through topic 1 because you guys really need, largely you guys really need the most beginner's introduction to programming, and this is an introductory course, so. The beginner solver's high when you got the bonus. Yep. When would the second assignment be released? Probably at some point this week. Next Monday morning at the very latest, but sometime this week. You can't download the assignment. It keeps taking you to WinRAR. I think you might have a virus, my friend. Or something. I don't know. It's not an archive. So, or maybe it's just, if something is interfering with your browser such that your links when you click them are being redirected to third-party sites, I would say that's probably a bad thing, and you should probably see. You should have a specialist look at that. If you submit assignment 1 on Jupyter, then you don't need to submit it again on Avenue. Correct. You may submit on Avenue. You may submit on Jupyter. Both are equally valid means of submission. If you submit on both, you'll make Basil a little bit annoyed, but, we'll take whichever of those is the most recent. It's it's not necessary to submit in both places. They are intended as parallel paths for submission. Not there is a redundant mechanism for submission. That doesn't mean you have to use both of them. No trouble. What if you upload Avenue... what if you upload the assignment onto both Jupyter and Avenue at precisely the same time? I'm not gonna make promises I can't keep. I was going to say something like, if you can manage that, then, you know, probably I should mark both of them and give you double the marks. But no, I'm not gonna do that. If you manage to upload both of assignments to both of the parallel submission things, then you get your Jupyter version marked. So what does the raise not implemented error mean? So that's basically a thing where that's a thing for Python where if you haven't finished something, you can put that in so that you can still run and compile the program without that being completed. Because it makes it syntactically correct. You delete that line. Yes, thank you, Adam. Yeah. Yeah. Please delete that not implemented error. You can think of that as a your code here tag. Although we also have your code here tags in the code. Yeah. Okay, well, you guys have class to get to. I've got stuff to do too, you know. Hello, Monday. Hopefully this was a good class for everyone. Take her easy, folks. Keep it real. Keep it on the DL. Etc., etc., etc.